Hello, everyone. We're going to go ahead and get started on section 7.3, which is going to be on simple interest. So as an overview, whether you want to buy a house or a car or have a credit card or invest money or take out student loans or have a savings account, you most likely have to deal with interest, a fee that you have to pay in order to use the money. Even there are lots of more things that even use interest than even just these examples, but these are the most common examples. So there are two types of interest. There's simple interest and compound interest. Compound interest is what we'll go over next section, but simple interest first is just a one-time percent of an amount of money, while compound interest is going to be a percentage of your original amount plus a percentage of the new amount every time it recalculates interest every specific period of time. So simple interest is like the name, it is simpler. It is only calculated one time when you borrow that money. So simple interest can be calculated at a specific rate and based on like certain amounts of time and things like that as well. So simple interest, in order to compute some simple interest, we're going to go over some vocabulary. So first, interest is typically wrote with an I. So interest I is the fee charged for using money. So it's a simple interest in our case. Principal, P, is the amount of money borrowed or placed into the savings account or invested or anything like that. Then R is the rate. And that is the percent of the principal paid for having money loaned or earned for investing. So that'll be the rate at which you gain that interest. Unless indicated otherwise, rates are given as a percent for 1 year and are always written in decimal form when doing calculations. So like how we did things with percentages in our last section, we always want to change this into decimal when we actually calculate things. Then we have time or term. It's typically time, it's given as T. The length of time money is being borrowed or invested. And the rate is given as percent per year. The time needs to be in years. So when you calculate things, the time needs to be converted into years if it's not already in years. Then future value is A. So we say A is the amount of the loan or investment plus the interest paid or earned. So how much is this investment going to be in some amount of years? So we have our equation for simple interest. We have interest is equal to the principal times rate times time. And it looks like PERT. So interest equals principal times rate times time. So it's just those values being multiplied together. The future value is equal to the principal plus the interest. So whatever the original amount was and the interest gained during that time. So we say future value A is equal to principal plus interest. Let's say you didn't quite calculate interest already. You can actually create another equation for future value if you don't already have interest. So the other way you could write this, saying future value is equal to the principal times 1 plus the rate times the time. So if you don't have interest yet, this is also the way that you can calculate future value without the interest. So those are going to be the two equations that we'll use for the rest of the section. All right, so first example, calculate the following situations using the simple interest and future value formulas. So we'll use each formula. Part A, we have find the simple interest for a $12,000 loan for 5 years at a rate of 7%. So we're taking out this loan, it's $12,000 for 5 years. So your loan or your principal, the original amount is 12,000 and your time is 5, representative of years. And the rate itself is 7%, which as a reminder, we always want to change to be a decimal. So 7% would be 0.07 in decimal. And in this case, we're finding the interest, so we're using our equation I equals principal times rate times time. So this is all for information kind of summed up here. Principal is 12,000, rate is 0.07, the time is 5 years, and we have interest equals principal times rate times time. So we plug our values in. We say our interest is equal to the principal, 12,000, times the rate, 0.07, and the time, 5. So we multiply these values together, put it in our calculators to get that the interest should be $4,200. So that's how much simple interest you would gain on a loan at that rate for 5 years. All right. Moving on to part B. We'll find the future value for a $12,000 loan for 5 years at a rate of 7%. So it's the same question. We have the same principal and rate and time, except now we're finding the value of this loan after 5 years. So same information. Principal is $12,000, rate is 0.07, time is 5 years, but now we're going to use our equation for future value. Let's go ahead and use the slightly more complicated version of our equation for future value. And then once we do, we can just confirm that this is the principal plus the interest. So we'll use our more difficult equation here. We have future value is equal to the principal times 1 plus the rate times the time. We have all these values, so we'll go ahead and plug them in. We get that A, or the future value, is equal to 12,000 times 1 plus 0.07 times 5. Now, since R and T are being multiplied, those need to be multiplied first, and then added to 1. So we plug these in our calculator, and we end up getting that our future value of our loan would be $16,200. We said that our future value is the principal plus the interest. Our principal was 12,000 and our interest was 4,200. Add those together, that equals 16,200. So we use our more complicated equation to just verify the simpler equation was correct. So all right, let's do another example. We have Admiral Chauffeur Services borrowed $600 at 9% simple interest for 1.5 years to repair a limousine. Find the future value and the monthly payment. So in this case, we're only finding future value, not necessarily simple interest. And we'll also find the monthly payment. And it's 1.5 years. We're giving it as a fraction form, but we can change that into decimal. We do like using decimal probably more in our calculations anyway. So, all right, let's go ahead and do this one all together. All right, so here's our question once again. Borrowing $600, 9% simple interest for 1.5 years. We're finding future value and the monthly payment. So we want to find the future value first. Once we find the future value, we'll be able to figure out our monthly payment by just dividing by 12. So starting with the future value, we know why we have two equations for future value. We have the one where it's principal plus interest, and then we have the one that we don't necessarily need the interest. In this case, we don't have the interest, so let's go ahead and use that equation. That equation was A is equal to principal times 1 plus RT. So this is the equation that we're going to use. And while we're at it, let's go ahead and just establish what these values are, what our principal is, what our rate is, what our time is. So we'll go off to the side. We say principal was the original amount borrowed or loaned or invested. In this case, that's $600. Then we need to know our rate as well. We said the rate was 9%, but remember we want that in decimal. So in decimal, this would be 0.09. That is 9%. And lastly, we want T for time. Time in this case is 1.5 years, but it's written in a fractional form. So we want to remember that something like 1/2, 1 divided by 2 is really 0.5. So if we're talking about 1.5, it's really 1.5 years. All right. It's easier to work with one form of whether it's decimal or fraction. It's not as helpful when we kind of mix them all together, so we will keep them all in decimal in this case. So all right, calculating our future value. We have our equation here, so we'll go ahead and just plug in our values. So our future value will be equal to our principal, which was 600, times 1 plus the rate, 0.09, times 1.5 for the time. Little dots in the center there indicates multiplication. I put some extra parentheses around the rate and time just to make it clear that that's what we want to calculate first. And then we'll go ahead and multiply this out. So we can either plug it in our calculator as is right now, or we can take it in a couple steps. So let's do a couple steps. So let's go ahead and multiply 0.09 and 1.5. This would give us 600 times 1 plus 0.135. So we can go ahead and add those together. Simplify it out. This will be 600 times 1.135. We add those together. Lastly, go to our calculators, multiply this out. We should get our future value. Should be $681. So if you borrow $600 at 9% simple interest at a year and a half, your future value should end up being $681, meaning that interest was $81. Now we want to find the monthly payment. Now the monthly payment, if we know this future value, and we're going to be paying it off in the course of the time of our loan, we want to go ahead and write that out. So we have 1.5 years for our monthly payment. We want this to be our future value divided by time. But we want our time in months because that's what we're calculating, monthly income. Our time for us is 1.5, so 1.5 years. So time in years is equal to 1.5, we want to go ahead and multiply that by the number of months in a year, which is 12. Months in a year. 1.5 times 12 is 18. So T equals 18. This is in months. So 1.5 years is really 18 months. So we'll go ahead and plug that in for our monthly payment. We got $681 divided by our time in months, which in our case is 18 months, 1.5 years. So we go in our calculators, we calculate this out, we round to the nearest second decimal place because it's cents, and we should get that our monthly payment should be $37.83. So there's our monthly payment and our future value. All right, let's go ahead and head on back over to the lecture. All right, so we wrapped up this example. Moving on, we want to be able to find the principal, the rate, or the time. So now we're going to work in a different kind of way. So in addition to finding the interest and future value of a loan or principal, we can also actually find the principal, the rate, or the time by substituting the given values into the formula interest equals principal times rate times time and solve for the unknown. So let's say, for example, you don't know the time, but you know the interest and the principal and the rate. You could plug all those values in and then be able to solve for time, because that's the only unknown that would be left. As a reminder, you always want to make sure to change decimal to percent, since rates are given in percent when given to you, but when calculated, they are in decimal. So it's always something to be aware of. And here we go one more time, percentage to decimal conversions. So we have a percentage. To make percent to decimal, we take our decimal place and move it 2 spots to the left. So 2.5% would be 0.025. To change decimal to percent, we do the opposite. We take our decimal place and move it 2 spots to the right. So in here, we would have take that decimal point, go 1, 2 to get 2.5%. So just a reminder on how we do that. So we'll be using the same formulas that we have in the past and how we've gone over already, and we're just solving for something that isn't necessarily future value or interest. So let's do an example. We say if you invest $8,000 for 30 months and receive $1,000 in simple interest, what was the rate? So we've given some info here. We're investing $8,000. So that's the principal for 30 months. Okay, it's time. It's given in months though, so we definitely want to convert that to years. And we're receiving $1,000 in simple interest, meaning we know simple interest, is 1,000. So these are all the pieces of information that we know. Principal is 8,000, interest is 1,000, time is in 30 months. We always want to put that in years, so if you're given months, you can divide by the number of months in a year, which is 12. So 30 divided by 12 is 2.5, so 2.5 years. And there's nothing about future value in this question, so we are going to use the simple interest formula. Interest equals principal times rate times time. So we'll go ahead and plug in the values that we do know. We know that interest is 1,000, principal is 8,000, and the time is 2.5. So we can write 1,000 equals 8,000 times R times 2.5. Let's simplify that a little bit. We can multiply 8,000 times 2.5. That gives us 20,000. So 1,000 is equal to 20,000 times R. Now our last step in order to solve for R would be to divide by 20,000. Since it's being multiplied, the only way to get rid of that number would be to divide on both sides. So we'll divide both sides by 20,000. We'll get our rate, is equal to 1,000 divided by 20,000, which we put in our calculators and get that should be 5%. When we put this in our calculators, it will tell us 0.05. But remember, we want to put that into percentage. So we move our decimal spots, two spots, in this case to the right, to go from decimal to percent, and this gives us 5%. So it's always good to remember those conversions for at the end to figure out exactly what you need to give. So, all right, there was one example where we kind of solved for something else using the same formulas that we've already been given. So moving on to something called the banker's rule. Simple interest for short-term loans is sometimes even computed in days. So these would be loans that are just maybe a couple months, maybe 100 days, something like that. So very short-term loans, not quite a year. The banker's rule treats every month like it has 30 days. So it treats a year like it has 360 days. We know that a year has 365 days and 366 on some years. But the banker's rule just says every month has 30 days, so an entire year is 360 days. It calls it a day. So bankers have this rule because when interest had to be calculated by hand, it made calculations a lot simpler to use 360 instead of 365. Since we have things like computer programs nowadays, it's definitely nowhere near as much of an issue because nobody's calculating these things by hand anymore. But they do it because it makes them more money. They get more money out of it by using 360 instead of 365. So we see an example here on the side. We say, for example, on a $5,000 loan at 8% for 90 days, the interest would be this for a regular year. Interest equals principal times rate times time. Principal is 5,000. The rate is 8%, 0.08. And our time, we always write as a fraction, which you can turn into a decimal. We have a fraction of the number of days divided by the number of days in a year. So however many days the loan is divided by the number of days in a year. So our portion of the year is 90 days divided by 365. Then we put that in our calculators and we get $98.36. That's how much interest you should be owing on that. But using the banker's rule, we see it does come out differently. 5,000 times 0.08 times 90 divided by 360. So changing it from 365 to 360. That comes out to $100 even. So we see in that case, you owed more. Sure, it was only about like $1.64, but imagine if that loan was for a lot more money. You could end up owing a lot more in that case than what you should be owing. So it's always good to be aware of these things. Once again, this is called the banker's rule. So it is a way that kind of cheats you out of some money. So it's things to be aware of. So all right, let's go ahead and try it out. Try calculating something with banker's rule. So the simple interest on a $2,200 loan at 7% for 100 days is $42.19. We say that is how much it is basically for a regular year. So how much would it be if you use the banker's rule? So just to preface this, anytime that you're told a specific number of days and like banker's rule does not come up in the question, you are using 365. If banker's rule shows up in the question saying, calculate this in banker's rule, what would this be in banker's rule? Anything along those lines, that's when you use 360. You're always going to want to use 365 when you're calculating things that go by the day, whenever you do anything not related to the banker's rule. So do keep that in mind. You're not going to use 360 as like representative of days in a year for all the problems from now on. It's always 365. But we are going to do it to use the banker's rule. So we know that simple interest should be $42.19. We're going to see how that changes with the banker's rule. Okay, we're told that the loan itself is $2,200. The rate is 7%, so in decimals, 0.07. And it's 100 days. So our time will be 100 days divided by 360 for the banker's rule. So here we have it. Our principal is 2,200. The rate is 0.07 and time is 100 days. But remember, it's always out of a year. So it'd be 100 divided by 360 using banker's rule. So we'll go ahead and plug this into our regular simple interest formula. We'll say interest is equal to 2,200 times 0.07 times 100 divided by 360. So we can plug these into our calculators, and we end up getting the interest should be $42.78. So we do definitely see that our interest was higher using the banker's rule. And once again, this is not necessarily a lot of money. I mean, it's not even $1 at this point, but once you have larger amounts, this can be very different. So it is different. Usually banker's rule will make the values higher, which if you're investing, that's good. But if it's a loan, not very good. So, all right, there's an example using banker's rule. Just one more time. You only use 360 for days in a year, but it's banker's rule, nothing else. So, all right. Our last thing here is discounted loans. Sometimes the interest on a loan can be paid for upfront by deducting the amount of interest from the amount the bank gives you. And this is called the discounted loan. Interest that is deducted from the amount you receive is called the discount. So they say things like, oh, just pay for your interest outright right now, and I'll just deduct it from the loan. You don't pay interest on it anymore. It sounds great. But it's not quite. Since you're paying the interest up front out of the amount that you're borrowing, the effect is that you're really borrowing less money and you're paying the same amount of interest. So you're borrowing less money from the get-go with this same amount of interest on those two different amounts. The higher amount, the original, and the lower amount that you actually borrowed. The actual interest rate that you pay will actually be quite a bit higher than the rate you were originally quoted for. So if you're ever offered a discounted loan, you should probably not take it. You should probably run away. So the interest that you end up paying will be higher depending on like the value of the loan and everything. So we'll go ahead and we'll see how that works out in our next example. So here's our example. Mary obtained a $5,000 discounted loan for 3 years, 6% simple interest. So for part A, we're going to find what is the discount. B, we'll find the amount of money that Mary actually received. And then we're going to find the true interest rate. So we'll go ahead and calculate that out in our example. All right, so here's our question. Mary obtained this $5,000 discounted loan for 3 years at a 6% simple interest. So for A, we're going to find the discount. So what we're going to do is calculate the simple interest that would have gained on this loan, and then we will subtract it from the amount from the loan to get part B. So for part A, all we need to do is calculate what is the simple interest that would have been earned. That will be the discount. So for part A, we're going to use our equation. Interest equals principal times rate times time. We'll go ahead and find the values of all of these. So we're told that it's a $5,000 loan, so our principal is $5,000. Our rate is 6%, which in decimal is 0.06. This is 6%. And the time is 3 years. We know that time indicates years. We don't necessarily have to write years. All right, so we'll go ahead and plug these values in. So we get interest is equal to the principal, 5,000, times the rate, 0.06, times the time, which is 3. So plugging all these numbers into our calculator and multiplying them together, we should end up getting this would come out to $900. So the interest that is calculated for the amounts that we are given right now is $900. So the discount is $900. So your discount is just the amount of simple interest you would have gained during that time. So when we go to part B, when we find the amount of money that Mary actually received, the amount that she received would be the principal minus the discount, which for us, this is 5,000 minus 900, making the amount that she actually received $4,100. So that was the amount Mary actually received. But if we go ahead and we find the true interest rate, this might be a little bit different. So Mary received $4,100. Now, if Mary had just taken out a loan for $4,100 with all the same rates, we'll see how much that actually comes out to. So going on to part C, when we calculate this now, we're still using our interest formula, and interest equals principal times rate times time. But now we're saying the principal was $4,100. That was how much she actually received. With, once again, the rate is what we want to find. So we don't know the rate, but we are told the interest would be $900 from part A. That's how much our interest rate should be. And our time is still 3 years. So in this case, we're finding kind of the true interest rate. So we'll go ahead and plug these values in. So interest was 900. Principal was 4,100, times the rate, which we don't know, times the time, which is 3. So we'll go ahead and multiply these together. Multiplying 3 by 4,100, we get 12,300 times R. We want R by itself, so we can go ahead and divide both sides by 12,300 to get rid of it on the right. So these values will cancel. We get that R is 900 divided by 12,300. So we go in our calculators, we find what this value is equal to. We would say that this is about, when we calculate this out, 0.0732. Now remember, we want percent, so we'll go ahead and grab that decimal point and move it 2 spots to the right. This really makes it about 7.32%. So using all the same values and everything, if we actually took out a loan for $4,100 and the simple interest should have been $900, the rate really was 7.32%, not the 6% that you were promised. So it does change when you take this kind of idea like a discounted loan, because you're really just taking money off the principal with everything else being the same. So your rate does change with discounted loans, so it will be higher than the promised percent rate that you were given in the first place. So it's always something to be aware of. So, all right, let's go on back over to our lecture. All right, we finished up this example, and that wraps up section 7.3. So, in section 7.3, we learn how to compute simple interest and future value, how to compute principal, rate, or time, how to compute interest using the banker's rule, and how to compute the true rate for a discounted loan. So, all right, that finishes up section 7.3, and I'll see you in the next one.